Okay, so we left off in section 9.6. So we're talking about rational equations. And we were multiplying through by our least common denominator so that we cleared our fractions and just had a simpler equation. All right, so we did do number 4. And when we solved number 4, we got 2. But when we went back and we checked, we plugged 2 in and we got undefined, right? 1 over 0. So that means that 2 was not our answer, so there was no solution for number 4. All right, so that's called an extraneous solution. So it's a derived solution that's not a solution of the original equation. If you plug it back in to check, you get 0 in the denominator somewhere. All right, so were there any extraneous solutions? Yes, in number 4, right? Alright, so let's do some kind of challenging ones. Alright, so it says Gabby can finish a 500-piece puzzle in about 8 hours. Gabby says she's much more talented than that, so let's pretend it's a 3D puzzle, one of those really hard ones. When Gabby and Rachel work together, they can finish the puzzle in about 4.5 hours. How long does it take Rachel to finish the puzzle if she works by herself? Okay, so when I taught at IU, they always had these questions, and it drove me crazy because my students always said, oh, 3.5 hours. Did you guys see what they did? They took 8, they subtracted out 4.5, and I said it would take 3.5 hours. That doesn't make sense, because working together, it takes them 4.5 hours. So maybe Gabby is just slowing Rachel down, and Rachel's really speedy on her own. She can do it in 3.5 hours, not even working together, right? That doesn't make any sense. So working together should take them less time than it takes working by herself. Okay, so it cannot take Rachel 3.5 hours. That doesn't make any sense. All right, so we need to think about how much of the job each can finish per hour. Okay, so what I always think of, so I'll say Gabby. So what amount of the job can you do in 1 hour? So in 1 hour, she can do some amount of the job. So what fraction of the job? Okay, if it takes her 8 hours to complete it, in 1 hour she can do what fraction? 1/8. Does that make sense? So she can do 1/8 of the job. Rachel, we don't know how long it takes her in 1 hour, so we're going to say in 1 hour she can do 1 over x of the job. So in other words, it takes her x hours to complete the job. And then together, they can do 1 over 4.5 of the job. So you're just doing 1 over, 1 over, 1 over. Okay, then you set up an equation. So it's Gabby plus Rachel equals working together. So 1/8 plus 1 over x equals 1 over 4.5. And that's your equation. Okay, so this is saying in 1 hour she can do 1/8, Rachel can do 1 over x, so together they can do 1 over 4.5 in that 1 hour. Okay, so we need to solve. So we're going to solve just like we did yesterday. So we want to look for our least common denominator. You could probably find a number less than what we're going to use, but we're just going to take the 8, the 4.5, and the x. So all 3 things. And we're going to multiply that into our entire equation. Okay, so remember the trick that we talked about yesterday. You're not going to draw lines to cancel, right? You're thinking of taking your fingers and covering up the things that are canceling for each one. Because this whole thing is going into each piece. Okay? So on the first one, it's like I'm taking my fingers and I'm covering up the 8 and the 8 because they're going to cancel. Okay, I would be left with 4.5, x, and 1. Okay, so I have 4.5x. Okay, on the next piece, so the 1 over x, I'm going to cover up the x and the x. That's what they have in common. So I'd have 8 times 4.5. 36. All right, thank you. Equals, on the last piece, I'm going to cover up the 4.5s. So I have 8x and 1. So 8 times x times 1 is 8x. This is a much easier equation to solve. So subtract the 4.5, you get 3.5x equals 36. Divide by 3.5. I heard someone clicking away. Didn't somebody get it? Point. It should be bigger than that. I think you divided it. 10.3. Yeah, did you do the opposite way? So 10.3. So it would take Rachel 10.3 hours if she was working alone. Okay, this should make kind of intuitive sense. If you had something like this on the SATs and you had some different choices, one of the choices would probably be 3.5. You might have 8 hours, 7 hours, 10.3, I don't know, 7.5. Let's say you have those different choices on the SATs, and this was a question. Okay, think about it logically. Okay, if it takes Gabby 8 hours to complete the puzzle by herself, let's say it took Rachel exactly the same amount of time, 8 hours to finish it herself. How long would it take them working together, you think? 4, half that time. Okay, so notice it's taking them together 4.5 hours. That means that Rachel is not as fast as Gabby. Okay, so that means anything that is less than 8 you can get rid of. So you can get rid of 3.5, you can get rid of that, you can get rid of that. And you can actually get rid of 8 because then it would be 4 working together. So the only choice left would be 10.3. See how that works? So use common sense on standardized tests if you have a question like that. All right, so let's try another one. Okay, a jet travels 4,000 miles from Indianapolis to London and 4,000 miles on the return trip. I doubt you can get a nice connecting flight like that, or a nice flight with no connections like that, but the total flying time is 18 hours. The return trip takes longer due to winds that generally blow from west to east. Okay, does this make sense? When you guys fly, sometimes on the return trip, it takes so much longer. All right, so if the jet's average speed with wind is 480 miles per hour, what is the average speed of the wind during the round trip flight, round to the nearest miles per hour? So, oh, this should say without wind. It's just covered up with so with no wind. Okay. So round to the nearest mile per hour. Okay, I set up the table for you. If I put this on your test, it would most likely be a bonus. Right? You would have to set up the table. So here's the chart. So we have distance, rate, and time, right? Distance is always equal to rate times time. Okay, both distances are 4,000 miles. So Indianapolis to London. All right. If I have no wind, it just takes 480 miles per hour. If you have the wind on your back, you're going to go faster, right? So your speed with the wind, you add on the wind speed, 480 plus W. The speed against the wind, you're going slower, so you're subtracting out. So if the wind was like 50 miles per hour, you're now going 480 minus 50. You're going 430 miles per hour. Okay. And then the last column is the one that you have to figure out from the other information. So if I was solving for time, time is distance divided by rate. So do you see where they got these numbers now? So they had 4,000 divided by 480 minus W. Okay, the other one was 4,000 divided by 480 plus W. Okay. What was I given in the problem that I have not used yet? Yeah, the total flying time. So there and back is 18 hours. All right, so total time is 18 hours. So that means I have 4,000 divided by 480 minus W plus 4,000 divided by 480 plus W equals 18. So you're taking the two times and adding them together. Okay, once again, we need the least common denominator. So your least common denominator has to be both things. So it's going to be 480 plus W and 480 minus W. So I'm going to multiply it by my entire equation. Okay, so think about it. So on the first piece, 480 minus W, 480 minus W is going to cancel. So I'll have 4,000 times 480 plus W. Okay, so let's write that. So 4,000 times 480 plus W. Okay, on the next piece, 480 plus W, 480 plus W, those are going to cancel. So I'd have 4,000 times 480 minus W. And the last bit, there's no denominator, so it's going to be 18 times both pieces. 480 plus W, 480 minus W. I'm going to give you guys a second to see if you can simplify it. So try to simplify. So you're going to have to FOIL the 480 plus W, 480 minus W, which is actually kind of nice, right? Because it's the difference of two squares, so you don't have middle terms. So you can do that. Okay, you guys should be getting pretty big numbers, right? So you get 192,000 plus 4,000 W plus the same number, 192,000 minus 4,000 W equals, I'm going to have 18 times, when I FOIL, I get 230,400 minus W squared. So the 4,000 W minus 4,000 W goes away. So on the left side of the equation, you have 384,000. So 3,840,000 equals, multiply the 18n. So you get 4147200 minus W squared. This is all looking familiar. Do you guys have the same numbers? Okay. All right, when you subtract the 4 number over to the left side, you get negative 307,200 equals negative W squared. So just divide by the negative, so you get plus and plus. I want to get rid of the square, so take the square root. Now I feel like I messed up. Oh, I have 18. I forgot my 18 with my W squared. 18 W squared. I realized when I was getting the wind was 500 miles per hour. Maybe I did something wrong. All right, so divide by that 18 first. So you have 307,200 divided by 18. Okay, now take the square root of that answer. that what you guys got? Good. So about 130 miles per hour, 131, somewhere around there. Does it say round to the nearest mile per hour? So 131 miles per hour. So around there. Still pretty fast. It's up in the air, right? All right. So that's the types of story problems that you'd have with these rational equations. So like working together problems, distance equals rate times time problems, things like that. All right, so let's try a rational inequality. Okay, so we've done rational equations. Rational inequalities are pretty similar, but we need to use critical points. Do you guys remember using critical points when we did parabolas? Yeah. So you had to like check on each side of the critical point. Okay, so we're going to do that. Okay, so there's two pieces that you need to do. So the first thing is to find the value of x that makes the two sides equal. Okay, that's going to be one of your critical points. And then the second one is to see what makes the denominator equal to 0 as well. Okay, that's also going to be a critical point. Okay. Now you guys know that if you have an inequality, so you have like less than, greater than, whatever, and you multiply by a negative number on both sides, what happens? You flip the sign. So what happens on these problems is we don't know if x is positive or negative. So if I'm multiplying it over, I don't know if that sign's still going to be less than or if it's going to be greater than. I don't know if it flips. Okay, so we have no idea what x is. All right, so we ignore the less than or equal to sign. We just look at it as if it's equal. So I say equals 3. And I solve. Okay, I'm going to multiply my x minus 6 over. So I get x equals 3 times x minus 6. That's the same as multiplying through by your least common denominator, right? If I multiply by x minus 6 on both sides, on the left side it would cancel. On the right side I have 3 times x minus 6. So I get x equals 3x minus 18. Subtract the 3x, you get negative 2x equals negative 18, so x equals 9. Okay, that's one of the points that you put on your number line. So that's a critical value. All right, so that's the first thing you do. The second thing you do is set the denominator equal to 0. So we say x minus 6 equals 0, so x equals 6. That's the second critical point. So these are critical points. All right, so we put that on our number line. Now we're just testing back in the original. Okay, so I want to test numbers on the left, in the middle, and on the right. So let's test 0. That's on the left of 6, right? So if I test 0, I'd have 0 over 0 minus 6 is less than or equal to 3. That is 0 over negative 6, so 0 is less than or equal to 3. True, false, true. All right, let's test between 6 and 9. So let's try like 7. So if I try 7, I have 7 over 7 minus 6 is less than or equal to 3. So that's 7 over 1, so 7 is less than or equal to 3. False, right? Doesn't work. Let's test 10. So if I test 10, I have 10 over 10 minus 6 is less than or equal to 3. So I get 10 over 4, so like 2.5 is less than or equal to 3. That's true. So I know that I'm going to shade on the left and on the right. Okay. The tricky thing about these problems is one of your endpoints can be filled in, one can be open. So think about testing the number 6 and the number 9 into your original. What happens when you plug 6 in? Undefined. So that's not going to make it true. Okay, so 6 is open. So you can write yourself a little note. 6 makes original undefined. Okay, what happens when you try 9? You get 9 over 3, so that's 3. You get 3 is less than or equal to 3. That's true. So 9 is filled in. If it just said less than, if it didn't say less than or equal to, 3 would not be less than 3, right? And it would still be open. But if you have less than or equal to, one's going to be filled in, one's going to be open. Okay, so your final answer is, remember your interval notation, negative infinity to 6, parenthesis, union, bracket, 9 to infinity. So the bracket indicates that it was filled in on 9. Okay, one more. Oops. All right, so 6 over x minus 8 is less than 3. So you guys want to try this one? So remember, you have two things that you're trying to find. So 2 critical points. Then you're going to test your points on the left, in the middle, and the right. Okay, I'm seeing a lot of right answers as I go around, so it looks like you guys are understanding. So remember, the first thing is just pretend that it's an equal sign and solve. So we're just multiplying that x minus 8 over. You can think of it as cross multiplication. Like some of you are having trouble with it. So think of it this way. If you cross multiply, you'd have 6 equals 3 times x minus 8. So you get 6 equals 3x minus 24. Add the 24 over. You get 30 equals 3x. So x is 10. Okay, so that's one of your critical values. All right, the second one comes from setting the denominator equal to 0. So x minus 8 equals 0. So x equals 8. What if you had something else on the denominator? What if you had like x minus 8 and x minus 2? Yeah, you'd have like 3 critical values, right? So maybe even 4. All right, so you would need to solve that as well. So you get x equals 8. All right, so then you check points. So let's try like x equals 0, x equals 9, x equals 11. Try them in the original. So if you have 6 over 0 minus 8 is less than or equal, or sorry, less than 3. This is negative 3/4 is less than 3. That's true. If you check 9, you get 6 over 9 minus 8 is less than 3. That's 6 is less than 3, which is false. If you check 11, you have 6 over 11 minus 8 is less than 3. That's 6 over 3, which is 2. Oops. Is less than 3. That's true. So we know that my shading is like this. Okay, then we need to think about the endpoints. So if you plug 8 into your original, you get undefined, right? Because you would have 8 minus 8 on the bottom. So that one has to be an open circle. It's not making that a true statement, right? If I check 10, so I plug 10 and I get 6 over 10 minus 8, so 6 over 2 is 3. So if 3 is less than 3. That's false as well, so that's also open. Okay, so that means that my final answer is negative infinity to 8, union 10 to infinity. So you guys love it when I do infinities and 8s. So mean. All right, I do want to mention one thing before you guys work on your homework. On the test, it seems like once you learn 9.6, you forget everything that you've learned in the previous sections. So when you have something like 1 over x minus 2 plus x over x squared minus 4, and you don't have an equal sign, you can't cancel the denominators. The only way you can cancel denominators, like multiplying through, is if you have an equation, because you're keeping that equation balanced, right? You have a left side and a right side, so when you multiply through by the same thing on both sides, it's keeping the equation balanced. You can't multiply through by x squared minus 4 on this and clear your denominators. Do you understand what I'm saying? Okay, you can only do that if there's an equal sign. So like on something like this, you can clear denominators. On something like the first one, you can't clear. So how about you guys go ahead and try those in your additional notes and see what you get. Number 2 may not be a pretty answer. I just made it up. All right, so on the first one, you guys noticed that you were missing an x plus 2 on the first fraction on the top and bottom. So that would change your fraction to x plus 2 over x plus 2 times x minus 2. In other words, x squared minus 4 plus x over x plus 2 times x minus 2. You can write it as x squared minus 4, it doesn't matter. So when you combine your numerators, x plus 2 plus x is 2x plus 2 over x squared minus 4. Now notice the 2x plus 2 does factor. How does it factor? 2x plus 2?
What?
2x plus 2, you can pull out a 2, right? So you'd have 2 times the quantity of x plus 1. But that doesn't cancel with anything that was in the other that was in the denominator, right? So you can leave it like this, or you can leave it in the factored form. It doesn't matter. Okay, on the next one, your common denominator is x squared minus 4, because that's x plus 2 times x minus 2.
Wait, would it be 2x plus 2?
Uh-huh.
Okay,
Okay, so when we multiply through on the first ones, the x minus 2's would cancel, so I'd be left with 1 times x plus 2, so x plus 2. On the next one, both things cancel, right? So I'm just left with x. On the last thing, just the x plus 2's cancel, so I'm left with 5 times x minus 2. So I get 2x plus 2 equals 5x minus 10. Get your x's on one side, so subtract the 2x over. So I have 3x minus 10 equals 2. Add the 10 over, I get 12 equals 3x, so x is 4. Remember, when you have equations, always go back and check to see if you got undefined. When we go back and check 4, all of the denominators are fine. The only things that would make it undefined are 2 or negative 2. Okay, so this is your answer. So 4 is the answer. All right, so I just want to make sure that you guys didn't get those two things confused, because I feel like every time I grade this Chapter 9 test, people will forget that first section we did, the adding and subtracting, or 9.2 actually. Okay, so make sure you don't try to clear out the denominators if you don't have an equation.